On July 1st, 2025, astronomers detect something tearing through our solar system, an object moving at 58 kilometers per second, faster than any comet ever recorded. They call it 3I Atlas, the third confirmed interstellar visitor. But the shock comes when the James Webb Telescope reveals it's breathing. It's pouring out 129 kilograms of carbon dioxide every second with an impossible chemical signature. 8 times more carbon dioxide than water at distances where comets should lie dormant. Every established rule just broke. If a comet can act like this, what isn't being told about what's really moving among the planets? And why are scientists now asking if this is natural or something far stranger? On July 1st, 2025, the Atlas telescope in Chile logs a faint, fast-moving object at magnitude 18. Threading through the star-crowded backdrop near the galactic center, the night crew Vitoran survey operators and graduate student switches from routine monitoring to rapid-fire checks. Trajectory software pings a hyperbolic path, the numbers blinking red, 58 kilometers per second. Not a local wanderer, not a returning comet. The object is inbound from interstellar space, moving faster than anything previously tracked, outpacing even Almumoa and Borisov. Confirmation demands more than a single night's data. Within hours, the Atlas team relays coordinates to observatories across the globe. Automated alerts trigger in Hawaii, California, and South Africa. On astronomy forums, amateur sleuth Sam Dean posts a pre-discovery image from June, catching the object weeks before the official find. That evidence, faint but clear, locks in the trajectory. The path is open-ended, not looping back. Every model points outward, away from the sun. Origin, unknown. Mission logs record the tension in real time. Operators debate the odds of a third interstellar visitor in less than a decade. And voice messages fly between continents, each new measurement narrowing the uncertainty. By sunrise in Chile, the object has a provisional name, 3I-ATLAS. The world's telescopes pivot to follow. For a few hours, every eye in astronomy is focused on a single, silent traveler from beyond the solar system. On August 6, 2025, in a secure operations room at the Space Telescope Science Institute, the James Webb team prepares to process the first IR-SPEC spectra from 3I Atlas. The instrument's detectors, tuned to the faintest infrared signatures, record a chemical fingerprint that no one expects. The data pipeline flags a carbon dioxide to water ratio of 8:1 in solar system comets. Water always dominates, 10 times more abundant than carbon dioxide, sometimes more. Here, the script is flipped. Carbon dioxide pours out at 129 kilograms per second, a sustained plume with no sign of fading or explosive bursts. Slack messages and internal logs capture the growing disbelief. Lead spectroscopist Dr. Alan Fitzsimmons checks calibration. Files. Hunting for stray light or software glitches. Every cross-check holds. The carbon dioxide signal is real, peaking at 4.26 microns with water vapor barely a trace. Cyanide, nickel, and carbon monoxide lines appear in the mix, but always as supporting players. The outgassing began while 3I-ATLAS was still 6. For astronomical units from the sun, far too cold for water ice to sublimate. Normal comet rules do not apply. The team reruns the reduction pipeline with alternate continuum models, searching for hidden bias. The answer is the same. The comet is breathing, but not like any comet seen before. The numbers echo through the anomaly review. 8 to -1 carbon dioxide to water. 129 kilograms per second. Activity starting in the deep freeze of the outer solar system. The chemical riddle only deepens as the spectra are released, setting the stage for a new kind of mystery. On May 7, 2025, TESS, the exoplanet hunting satellite, logs a faint but persistent brightening in a region of the sky, now known to host 3I-ATLAS. The light curve rises with mechanical steadiness, no steadiness, no sudden drops, just a slow, unwavering climb. Days pass, then weeks. The pattern holds. By the time ground-based teams catch up in July, the trend is unmistakable. This object has been active far longer than first assumed. The puzzle deepens as SPHRX, NASA's infrared sky mapper, trains its sensors on the growing Comet. Their measurements reveal a shroud of gas and dust stretching 348,000 kilometers across, more than twice the width of Jupiter. The scale is difficult to fathom. For most comets, a coma this size would signal violent outbursts, or episodic jets. Here, the expansion is gentle, almost disciplined, with every survey confirming a symmetric, stable envelope around the nucleus. Space survey teams pore over time-stamped readings from TESS, SPHRX, and a patchwork of amateur images. The early onset of activity weeks before solar heating should have triggered anything rules out ordinary water ice as the driver. Instead, the outgassing appears constant, a slow exhale that never falters. Each instrument working in isolation finds the same result. The phenomenon is real, not an artifact. 31 ATLAS is awake, and it has been breathing the entire time. Trajectory models for 3I Atlas refuse to settle into anything familiar. The orbital inclination clocks in at 175.11, a retrograde sweep almost perfectly aligned with the ecliptic statistically, a 1 in 500 shot. Models run by the ESA Mission Planning Group peg the odds of this precise alignment at just 0.2%. Perihelion defies expectation, the closest. Approach to the Sun lands on the far side, with Earth and every major telescope locked out of a direct line of sight. Only 7% of possible orbits would produce this configuration. A detail that does not escape seasoned mission designers. Within days, the anomaly becomes a flashpoint. On July 15th, Harvard astrophysicist Avi Loeb posts a preprint to Arxiv titled, "Is 3I Atlas Alien Technology?" The paper lays out the evidence, not just the chemistry, but the statistical unlikelihood of the orbit and the way each parameter seems to skirt easy observation. Loeb's argument is careful, couched in probabilities and caveats. But the implication is clear. If these numbers don't come from chance, what's left? The debate spills beyond academia. NASA's press office convenes emergency calls with the Department of Defense and NOAA. On September 14th, the agency issues a rare, direct statement. There is no evidence for artificial origin. Internal memos, later leaked, show a tug-of-war over wording, how to address public fascination without fueling conspiracy. Meanwhile, ESA analysts push for a rapid interceptor mission, citing the unique orbital window as both an opportunity and a puzzle. Peer review grinds on, with urgent papers stuck in limbo. For the first time, the question of intent, natural or otherwise, moves from the fringe to the center of the world's scientific stage. On September 15th, 2025, as the lunar eclipse reaches totality, telescopes across both hemispheres record a sudden, vivid transformation in the coma of 3I ATLAS, where hours before the shroud glowed a muted red. A green hue now pulses outward, defying expectations and stirring late-night observatory chatter. Polarimetry teams tuned to the faintest shifts in scattered light report an unusual negative polarization and optical signature more typical of distant trans-Neptunian objects than any known comet. Amateur astronomers flood online forums with unfiltered images and raw photometry, each frame capturing the spectral shift but offering no clear explanation. Theories circle in real time: diatomic carbon, perhaps, or some exotic chemistry unique to interstellar ice. Yet, without calibrated spectra or peer-reviewed data, the cause remains elusive. For now, the green glow is a riddle. Its meaning debated from Chile to Cambridge as every instrument races to keep up with a comet that refuses to fit any mold. Dynamical models trace 3.1 ATLAS to an origin nearly 7 billion years in the past, a wanderer predating the solar system itself. Its journey across interstellar space, measured in eons, now narrows to a closing window. October 30th, 2025 marks perihelion, the single closest pass to the Sun before the object accelerates outward, never to return. Mission planners at the Space Telescope Science Institute scramble to allocate final observation slots, aware that every delay risks losing irreplaceable data. With each passing day, the comet recedes, its secrets locked behind expanding distance and glare. Only weeks remain for the world's telescopes to capture the last signals from a visitor older than our planet. Countdown that science cannot pause. On July 1st, 2025, the Atlas survey detected 3I Atlas moving at 58 kilometers per second, the fastest interstellar object ever recorded. Webb's IR spec revealed a carbon dioxide to water ratio of 8:1, chemisignature never seen before in any comet. In continuous outgassing at 129 kilograms per second, over months. Data from TESS, SPHERX, and ground-based telescopes confirmed a stable 348,000-kilometer coma and persistent activity well beyond where water-ice comets become active. The object's retrograde path, rare alignment, strategic perihelion position fueled debate, including Avi Loeb's published question about possible artificial origins. NASA and ESA responded with coordinated observation campaigns, but withheld speculation. The September 15th lunar eclipse brought the unexpected, a sharp green glow, still unexplained by current data. As 3I Atlas approaches its October 30th perihelion, its precise nature remains unresolved. What is certain, in just a few months, this 7-billion-year-old visitor will exit the solar system forever, leaving behind only data and questions that science has yet to answer.